So next we're going to look at investigating increasing, decreasing, and the constant behavior of a function. This is kind of confusing for some people because when they ask you to state the intervals on which the graph is increasing, decreasing, and constant, a lot of people look up and down and say, well, it's increasing up to 29,000 feet, for example, and then it's decreasing to 0. Actually, what they want us to discuss is something along these lines. Okay, this graph here represents the altitude of an airplane at time t, which is in minutes after takeoff. And so what we want to know is that in between 0 minutes up to, I don't really even, oh, I guess that's supposed to go down to 40. I didn't do very good on that, did I? Okay, there we go. We're supposed to know that in that interval, the function is increasing on the interval from 0 to 40. It doesn't matter that it goes up to 29,000, okay? Then the altitude levels out. Let me use a different color here. Then the altitude levels out until 120 minutes. This is a constant behavior because it is flat. And so we'll say that the function, which is the airplane's altitude, the function is constant on the interval from 40 minutes to 120 minutes. It doesn't really matter if they're asking on what intervals is the graph increasing, decreasing, or constant, where it is 29,000 feet. We'll describe that a little bit later with something else, okay? And then from 120 minutes to 160 minutes, the airplane's altitude begins its descent back to the airport, and that represents that the function is decreasing because the altitude is decreasing on the interval from 120 minutes to 160 minutes. Now these are intervals for x, okay? And I wrote those in interval notation. Another way to express those intervals, remember, is we might say 0 is less than x is less than 40. That's what this is meaning, but here is another way to write it. These are not ordered pairs. For constant, it means when x is greater than 40 but less than 120 minutes, the function is constant. Okay, and the same thing for the decreasing. That means from 120 and between 160, the altitude is decreasing. The function is decreasing. Okay, so you can write those like they did in interval notation, but don't forget that those mean a compound inequality. Between there, between there, between there. Okay? Now, informally it says a function is increasing on an interval in its domain if its graph rises from left to right. If it goes up as you read it from left to right, a function is decreasing on an interval in its domain. If the graph falls from left to right or goes down from left to right and a function is constant on an interval in its domain. If it's straight across, horizontal, constant over the interval. Okay? So it says use interval notation. That's what the parentheses and the brackets and all that stuff, to write the intervals over which this picture of this function is increasing, decreasing, or constant. Okay? So what you want to do is you want to say, well, on this whole interval, all values of x that are less than 0, that whole thing, the function is going up, it is increasing. Okay? So it is going to be increasing on the interval from negative infinity to 0. Okay? The function is decreasing just in between 0 and 1 is where that function is decreasing. Okay? So we would say the function is decreasing in between 0 and 1. And then you see that the function is kind of just straight across right along here, okay? So we'll say that the function is constant from 1 to 4 in that interval. And because of the open circle, I'm going to put a parenthesis at the 4. If that would have been a closed circle, I would have probably bracketed up that 4. I don't know. So anyway, it's going to be constant on the interval for x in its domain from 1 to 4.